Let us take few other applications of dimensional analysis now. What are the commonly asked applications? I just give you few cases like this. The very first one here is, they will provide us an equation stating what is what out of that, barring few quantities, and they may ask you to write the dimensional formulae of those physical quantities which have been represented by x, y or z or any other unknown quantity like. I will give you an example this way. F into T is equal to MA minus BL. There is one equation given this way. Out of that, it has been mentioned that F is a force, T is given as time, M is mentioned as mass and L is given as length. What is what out of that one? He has mentioned few quantities out of the given equation. F is given as force, T is given as time, L is mentioned as length and M as mass. He has not given any sort of mention about A and B. Now the question is, find dimensions of or dimensional formulae for A and B. A and B are said to be two different quantities which are involved in the equation. But what are those two? He has not mentioned in the problem. Only thing what we have been asked to do in this case is, in spite of not knowing what are these two physical quantities, we have been asked to write their dimensional formulae. Now in this regard, a simple concept one has to get to our mind. In fact, force into time, the product of force and time is called impulse, which also can be called as a change in linear momentum. Now when this is impulse, you can now understand, when we subtract BL from MA, we are getting impulse. I repeat, when we are subtracting BL from MA, we are getting impulse. What is the very meaning of it? This MA must be impulse, BL also must be impulse, then only impulse minus impulse gives us impulse. That means in any physical quantity or in any physical equation in particular, when you are adding two quantities, both should belong to the same category. Like pressure plus pressure is valid, volume plus volume is valid, velocity plus velocity is valid, but pressure plus volume is not valid. It is not possible. Similarly, velocity plus acceleration is not correct. So acceleration plus acceleration, velocity plus velocity, or velocity minus velocity, acceleration minus acceleration, all these are valid. So whenever you are adding two physical quantities or subtracting a physical quantity from the other one, both should belong to the same category. Then only either we can add them or we can subtract one from the other. Now exactly that logic when I apply here, whatever the dimensional formula this F into T is having, same dimensional formula M into A also should have. Similarly, the dimensional formula of F into T must also be equal to the dimensional formula of B into L. That is the basic one should understand from the given equation. Therefore, come on, equate the dimensions of these two now. F into T is equal to m into A. Therefore, now I can write that A is equal to Ft by m. Don't once again think they are numerically equal. Numerically they are not equal according to the equation given. They are equal dimensionally. That is the point what we need to understand. So, if I write this way, F into T is impulse. Impulse is nothing other than linear momentum difference or change in linear momentum. So, we can say MLT inverse is the dimensional formula for the product of force and time. By mass, now M you take and cancel, then what is now left over? LT inverse is supposed to be the dimensional formula for A. Similarly, when I just take F into T is equal to B into L, then what is the dimensional formula of B is the question. F into T by L when I write. Let us write dimensions once again. M L T inverse, that is for impulse. By this time L, that is for length. Length getting cancelled, you are now left with M T inverse. That M T inverse otherwise is called as rate of change of mass. That is dm by dt, like that already every one of us we have come across in the concept called dynamics. While discussing about rocket propulsion, we find as a time lapses the total mass of the system that gradually decreases there. That is actually the quantity what this B is representing in the given equation. So, just by considering this logic, we can write the dimensional formulae for A as well as B. So, this is one model what we may be asked in different examinations like. Let us take one more example based on the same model. This time I just want to mention an equation this way. P plus A by V square into V minus B is equal to RT. If you just recollect once again, this is what we call it as Van der Waals equation. Out of that, P is given as pressure, V is said to be volume, R is universal gas constant, R is universal gas constant, and T is absolute temperature. So, in this given equation, it is mentioned that P as pressure, V as volume, R is universal gas constant here, and T is absolute temperature. The question what they can ask you is, find dimensional formulae of A and B. What is the dimensional formula for A? What is the dimensional formula for the quantity given as B? So, if you take here carefully, P plus A by V square is one single quantity we have in that equation. That is one single term. Overall, one can say here A by V square, we are adding that one to the pressure. When we are adding A by V square to pressure, it is very clear to say that A by V square must also be pressure only. Pressure only can be added to pressure, that was what we have discussed earlier. Therefore, this P and A by V square both should have the same dimensional formula. When such is the case, I can cross multiply to write A as PV square, where P is pressure, that is given in the equation, V is volume, that also has been mentioned in the equation as such. So, you can directly write their dimensions now. M, L inverse T power minus 2, that is the dimensional formula for pressure. Volume being L cube whole square, that now becomes L power 6. So, what is the dimensional formula for A now? It is M L to the power 5 T power minus 2. That is the dimensional formula for the quantity which has been mentioned as A in the given equation. And coming to the second point, that is B, directly you can write the dimensional formula of B there, because we are subtracting B from volume. Volume is V given, B we are subtracting from volume, that means B should have the same dimensions of volume only. So, what we can understand now, and directly we can say B is equal to L cube. So, no further calculation is required for writing the dimensional formula of B. So, A and B both have the dimensional formula like this now. So, sometimes they may ask you the question in a slightly different manner also from the same. A by B has the dimensions of what? A by B has the same dimensional formula of which physical quantity? You directly can understand A is M L power 5 T power minus 2 by L cube. This cancels twice. So, what is now left over here? ML square T power minus 2, that is the dimensional formula what we are getting after dividing A by B. And every one of us we can understand directly ML square T power minus 2 is the dimensional formula for work done, or you can even call it as energy. So, whether it is work done that is given as the options or energy that has been given in the options, whichever of course they give, you just can adopt one out of the two. And in fact, A and B in this equation are called van der Waals constants. That also you might have discussed in the chapters of chemistry. So, what we need to remember here, what is that quantity one need not know. Only thing is, what are the other quantities mentioned in that equation? If you know their dimensional formulae thoroughly, automatically you can estimate what is the dimensional formula of those or that particular quantity which has been mentioned as a constant in the given equation. So, this is one method or one particular model which of course can appear in any of the entrance exams. Like that, if you look at old papers, earlier papers, including JEE, I am talking, they have asked in the past few applications based on the same. So, one need to remember this one thoroughly. Let us take another application of dimensional analysis. This application, of course, if I take it, they give us a statement this way. If say mass, that is M, length, that is L, and acceleration, that is given as A. Mass, length and acceleration were fundamental quantities, Write the dimensional formula of energy. In true sense, in the very beginning of units and dimensions topic, we have already discussed that there were three fundamental quantities initially we have adopted. One is length, one is mass, one is time. Afterwards, under SI units, we have added few more quantities as fundamental, that also we are aware of. But here, this is a different kind of a model. He takes 3 quantities of his own choice, and if he says that these 3 were picked up or chosen as the fundamental physical quantities, what is the dimensional formula of some other quantity like energy in this example? So, what are the 3 fundamental quantities he is talking about? Mass is one, length is the second one, and acceleration is the third one. So, when you take these 3, energy is the one what I want. In reality, this can be worked out in 2 ways. One is a direct method. If you can adopt that method, you can go ahead with that. Otherwise, the second one is a calculation method. Now, let us check the first one, energy. We have a dimensional formula this way, ml square T power minus 2. If you can write this dimensional formula in terms of the dimensions of these 3 physical quantities which have been chosen as fundamental quantities, then you directly will get the answer. For example, if you look at here, I write this one m as it is. This L square T power minus 2, I write this one as L into L to the L T power minus 2 I can write. L square T power minus 2, I can write that one as L into L T power minus 2. Now, just look at here, m, is it not mass that is mentioned there? L, is it not length? And we know Lt to the power minus 2 is the dimensional formula for acceleration. Therefore, in place of this, I can write that acceleration as the third fundamental quantity. Now, what would be the dimensional formula for energy now? It is m L A. That is the dimensional formula for it. So, it is m to the power 1, L to the power 1, A to the power 1. That is the concept. But of course, every time it is not possible for us just to get the answer in this methodology. Therefore, we need to adopt a particular method for it. What is that adoption here? The third use of dimensions, you take that one. Making use of the third application or third use of dimensional analysis, which of course we have taken as to derive new physical equations by considering the relation between the physical quantities. So, what we can write in the same manner you look at now? I can say that energy is proportional to mass to the power x, length to the power y, and acceleration to the power z. I just want energy in terms of mass, length and acceleration. So, I have taken their powers as x, y and z. I have written that equation now. Now, every one of you can directly proceed with the remaining steps. So, what to do now? Write dimensions, equate the powers of mass, equate the powers of length, equate the powers of acceleration over here, and finalize the values of x, y and z, and finally substitute those values or those powers in this equation and get the result. So, what is to be done in this case? E, it is m L square T power minus 2. That of course you can write m to the power x here, L to the power y here, L T power minus 2 to the power z here. So, it is m power 1 you can understand. Now, you can write the same this way, m to the power x, L to the power y plus z, T to the power minus 2z. That is equal to m power 1, L power 2, T power minus 2. Now, come on, equate the powers of mass. You will be getting the value of x as 1. Equate the powers of time. You will be getting the value of z as 1. Equate the powers of L now. It is y plus z is equal to 2. Then y is equal to 2 minus 1. That also will be 1 again. So, I have got x as 1, y as 1 and z also as 1. So, straight away I can substitute them here. Therefore, energy is equal to m to the power 1, L to the power 1, A to the power 1. That is MLA. That is going to be the dimensional formula for energy as such. So, whether if you can work out this way directly, nothing second to it. But for every equation, it is not that easily possible. So, best suitable thing is, without wasting much of a time and energy there, straight away go ahead with the third use of dimensions and finalize the values of the powers as x, y and z. Then resubstitute them in this equation to get the correct result what is required. Let us consider one more application this time. That application I just consider it as the third one. It is once again a peculiar type of an application. He says, in a system of measurement, in a system of measurement, 10 units of mass is given as 1 kg. 4 units of length is given as a meter. 1 unit of time is given as 1 second. There is a system of measurement, probably a sort of a dream system. It is not going to exist in reality. So, a system of measurement is given this way. 10 units of mass in that system is equal to 1 kilogram. 4 units of length in that particular system is equivalent to 1 meter. 1 unit of time is equivalent to 1 second. Now, the question is, in the new system, whatever the system that has been adopted now, in the new system, 1 Newton is equal to how many dynes? 1 Newton is how many dyne? That is the question. So, let us take this one first of all. What is 1 Newton? 1 Newton is kilogram meter per second square. Kg meter per second square is called 1 Newton. That is actually mass into acceleration in SI units. Mass is kilogram and acceleration meter per second square. So, kg meter per second square we call it as a Newton. So, what you need to do now is, what is 1 kilogram? It is 10 units. What is 1 meter? It is 4 units. What is 1 second? It is 1 unit. In fact, it is by 1 square. Whether I write that one in the denominator or not, never mind. 1 square is 1 only. So, what is ultimate result over here? 40 units. So, what is 1 Newton in the new system? It is equivalent to 40 units. Likewise, if I ask you, 1 joule is equal to how many units? First of all, what is 1 joule we have to think of? It is m L square T power minus 2. That is the dimensional formula for that. You can even rewrite the same this way also. That is kg meter square per second square. So, 1 joule we can write like this as kg meter square per second square. Now, come on, write down the values given to us. 1 kg is 10 units again. 1 meter is 4 units, 4 square here 16 units. Time is same in both. So, what will be this value now? 160 units. That will now be the value of 1 joule. So, in such model questions, they used to think about or imagine about a particular system. In that system, some equivalent relations are going to be provided to us. According to the given values or relations, we need to estimate what is the value of a Newton, what is the value of 1 joule, what is 1 Pascal, what is 1 watt. Like that, all these conversions in terms of the new system what has been imagined there, one has to write as the results. So, this is actually the system what he is imagining, and that is the third application of dimensional analysis. Let us consider one more problem, one more example considering the same application. The question is given once again this way: in a system of measurement, in a system of measurement, it is given that A units of mass is equal to B kg. Similarly, C units of length is equal to d meter, and P units of time is equal to q seconds. Slight difference in the data what has been provided in the previous case and the data what we are considering in the present case. If you look at A units of mass is B kilogram, so first thing what you should do is, what is the value of 1 kg you estimate from this. B kilograms is equal to A units. Then what is the value of 1 kilogram? That is A by B units. Similarly, what is 1 meter you write here? C units of length is d meter. So, 1 meter is C by d units. Exactly on the same lines, I can write 1 second is equal to P by Q units. So, first and foremost, whenever they give so many kilograms is equal to few units like, then first thing what we need to do is, what is the value of 1 kg you estimate. What is the value of 1 meter? Likewise 1 second. These are the estimations to be made first. Now the question is, 1 Newton is equal to how many dyne? Again is the question. So, you can directly understand a Newton is kilogram meter per second square. Now, you can write what is a kilogram. It is A by B units. What is 1 meter? It is C by D units. What is 1 second actually? P by Q, but second square is to be taken in the denominator. So, P square by Q square in the denominator, I can reciprocate that one while bringing it to the numerator, Q square by P square. So, what you can write, 1 Newton is equal to these many units. Similarly, what is 1 Pascal for example? What is actually Pascal please? Newton per meter square is also called Pascal. That means, Newton already I have taken up here. I write the same thing. It is A by B into C by D into Q square by P square. Till that extent it is called Newton. What is 1 meter? We know it is C by D. It is per meter square. Per meter square means by c square by d square. I can bring that one to the numerator, writing d square by c square here. One d gets cancelled, one c gets cancelled, then what is now left over? You check it. It is a q square d by b p square c. That is so many units, in fact, is going to be the value of 1 Pascal. So, if you take up the conversions, once again can be taken up in the same manner. There is no change in that, because standard equations they are all. 1 Newton means kg meter per second square. 1 dyne, suppose if they ask you, it is gram centimeter per second square. Like that, what is a joule? It is either Newton meter you can write, or kg meter square per second square we can write. What is Pascal? Newton per meter square. What is 1 watt? It is joule per second. So, all these conversions, they are all standard most conversions. So, if you can remember the corresponding unit over there, conversion is a very simple issue over here. But this is also equally one of the very good models as far as units and dimensions part that is concerned.